Question 7. A portion of the implicitly defined curve, which is x squared minus x sine y is equal to y plus 2x is shown. Determine the equation of the tangent to the curve at the point 2, 0. Right, so equation of the tangent, what we're looking at is y is equal to mx plus c. Now m is what we need to find. Right, now if you have to observe this, x squared is just fine. Remember, y is equal to f of x. So what we need to apply over here is product rule, and then we are sorted. So let us find the reason why we are finding the derivative, because m is equal to f prime x evaluated at some x is equal to a value. So x is equal to 2, right? So in this case, since it's implicit, we need to evaluate it at 2, 0 to get the value of f prime x or y prime. I will actually call it y prime, right? So when you say y prime, I mean f prime x, right, for simplicity. Now x squared minus x sine y, let me write this equation down. So what we have is we are finding the gradient. So it's x squared minus x sine y. X squared minus x sine y is equal to y plus 2x is equal to y plus 2x. Guys, you can do this in 5 minutes. Very simple question. So we're finding dy dx, we're finding the derivative. So what we're finding is dy dx, right? We're finding the derivative. So this is 2x minus product rule here, right? So to find the product rule, differentiate x, you get 1. Leave the sine y as it is, plus differentiate sine y, you will get derivative of sine y is cos y, times, very important, y is a function in x, so times y prime, and then leave the x, times x, right? So that's what product rule done. And then the derivative of y is just y prime, and the derivative of 2x is just 2. Now recover, now let us go and simplify this. So we have 2x minus sine y minus x cos y times y prime is equal to y prime plus 2. We need to find what is y prime, right? So let's bring all the y primes over. So we have minus y prime. Let me take the y prime actually across and bring all the numbers over. So we rather just factorize it in that case. So let me take out y prime as a common factor. So I have a y prime on the left hand side and a y prime on the right hand side. So for the right hand side, I'm just going to get 1 plus the minus change into a plus, and we left with all these factors here. X cos y, that's y prime, and all the numbers and the terms that do not have y prime, take it over. So what we have is 2x minus sine y minus 2, right? So we do have an implicit expression for the derivative, which is y prime is equal to 2x minus sine y minus 2, that is sine y, let me just write it properly, minus sine y minus 2 over 1 plus x cos y. You don't have to do all these additional steps here. You can just go and substitute in here. You can just say at 2, 0 to recover what's y prime. If this is the x value, that's a y value. Or if we have already written it like this in this neater form, what we can say is m. Remember, we're substituting at 2, 0, x value is 2, y value is 0. That's the y value. We're going to find the equation of the tangent at 2, 0. So x and y value. Now, x is 2, so 2 into 2 minus sine of 0 is just 0, minus 2 divided by 1 plus x is 2 and cos of 0 is 1. So what we have is the gradient is equal to, that's 4 minus 2 is 2 over 3. So my gradient is 2 over 3. Gradient of what? That's a gradient of the tangent. And you can see this is an upward sloping line. Gradient of the tangent at 2, 0. Now y minus y1, equation of the tangent, is equal to m into x minus x1. So you have x value as 2, y value as 0. So y is equal to 2 over 3 into x minus 2, which is equal to 2 over 3x minus 4 over 3. That's the equation of the tangent line. Let me go back up. Right, let's just check it up. Yes, the y value should be a negative, and it's a positive slope, so m has to be greater than 0. Yes, that's what I have.